welcome back to the programming language series where we're going to build a statically typed and JIT compiled language using nothing but Python and LLVM. Today we're going to tackle if statements, conditional operators, and Booleans. So this is going to be the code that we're going to be able to compile by the end of this episode. We're initializing a variable. We have our new if statements in here. A equals 5. It's going to reassign. So we're going to go to our variable reassignment. A equals 5. We're going to set it to 69. Nice. If it's not, we're going to set it to 420. Sick. And then we're going to return A back and see what the program returns. So let me back out of here and cd into episode 8. First thing we're going to need is go to our token class. So I'm going to add a new region into here as comparison symbols. We'll put it underneath equal sign. So we're going to add the less than, the greater than, equals equals, not equals, less than equals, and greater than equals. So these are all the comparison operators we're going to add for right now. We're going to add two new keywords, our if keyword and our else keyword. And then we're going to add two more for true and false. These are our Boolean tokens. So now that we added all of these here, we need to set some keywords in our dictionary. So our if keyword is going to be equal to token type.if. We're going to have our else keyword, token type.else. True, token type.true. Then false, token type.false. Now I do have a couple of Gen Z slangs that I'm going to use for if else. So for if, we're going to say sus, because if's kind of sus. So token type.if. And then imposter for else. So token type.else. Now that we have sus and imposter in here, we have all of our keywords set up for if, else, true, and false. So we can move on into our Lexer and start actually making tokens from these. Alright, this is going to be a little bit of code, but we will run through it. So underneath our percent modulus sign, I'm going to paste in all of this. So we're going to do our less than sign first. Of course, we need to handle less than or equals. So we check if the next character in the source code is an equal sign. We'll read the character and then set that to less than equals. If it's not an equal sign, then we know it's just straight up less than sign, and we'll return that new token. Same thing for equals and equals. And for our bang, all we have right now is bang equals. So we don't have the actual bang operator or the negate operator implemented yet. That's going to happen in a later episode. So for now, I have slapped a to do, and we're just going to return back an illegal symbol for right now. Now that I have pasted this in here, I'm just going to get rid of my equals case from before. So we don't have two equals sign cases, but you'll just alter that. So you can pretty much copy and paste the first one and just change the symbols and the token types for each one. After you have all that done, we're ready to get into our AST. So we'll go to our AST. In our AST, we're going to have to add two more. We're going to add our if statement node type. So down here with our statements, we'll add if statement. Then we're going to add our Boolean. So our Boolean literal will go down here with our literal. Scroll down to the end of statements. Start to create. I'm going to copy and paste this so you guys can pause the video and get this copied down into your actual project, but I'll go over it. So if statement will take in a condition. So in our code right here, this is our condition. So a equals 5. So it's just some type of an expression. I have our consequence. That'll happen if the condition. If there's an else block, this will have all the code in that else block, or it'll stay none if there's not an else to it. So everything's the same. So we'll set our node type to an if statement. We'll set up our JSON. This right here is just in case this alternative ease of development. This is actually can be none. So I set just an inline if statement here. Turn back none if there's not an alt. Moving on into our Boolean, we can copy any of these AST nodes in the literals and just change it. So they're pretty much the exact same as the other literals. So we'll save that and we will go into our parser. So in our parser, we need to actually import both of our nodes we created. So our if statement. And we'll go down here. In our, we have precedences to add. So we'll go down here and I'll paste these. So we have our equals equals, and these are going to be set to our p equals precedence. Less than and greater than, of course, get our less greater precedence. Add these 6 precedences to our. Now we need to go to our infix parse file. We need to add our 6 more to our infix. All of these is just going to be for all of our tokens that we did above, and every single one of them will call our parse infix. We can go up to our parse prefix functions now. We need to add 3 more entries. One for our if statement. So if we have an if, we have a new function, parse if statement. If it's a true or a false, we want to parse that Boolean. So that'll return back our literals. The first thing we will implement is our if statement. So we'll go down to our parse, the end of our parse statements, region blocks. We'll just keep on scrolling till we're at our assignment. Do def parse if statement, take in self. We're going to initialize these 3 variables first. So our condition, consequence, and alternative. We'll go ahead and advance the Lexer past the actual if token. We'll take our condition, so self.parse expression. Take in the precedence type of the lowest value. After our condition, we're expecting a left brace. So if not, self.__ expect peak. Token type dot left brace. Now we're going to check to see if we do have an else block or not. So if self dot peak token is a token type of else. So if it is, we'll advance the Lexer or the parser past that else token. We're going to do the same expect peak function. We're expecting a left brace. And then we're going to fill in our alternative. We'll parse a block statement for that alternative value. Then we'll cop out of this if statement and we'll do if. So that's it for our parse if statement function. So we'll go into our parse. It should be at the very bottom. We'll just paste. I'll paste this in. It's a really short. All this is doing is seeing if the current token is a true token. And this will return back an actual Python Boolean. So that will set our Boolean in our AST node as well. So if it's true, this will return a Python true. And then that will become our Boolean. So that is it for the parser. So we'll check our work with main.py. We'll set compiler and run code to false. Now we will Python main.wrote successfully. So we'll go into our ast.json and we'll pull up test.lime as well. So we have our function, of course, our block statement, and we'll go into our let statement, and then we have an expression. The condition is a infix expression, so a equals e. If that's true, we have another block statement, and we assign a to 69. Nice. We have an else statement as well. So our alternative is another block statement where we assign a to 420. Sick. And then we end up returning a. So the AST is looking perfectly fine for right now. So we can move in and set our parser to false. First thing, as always, import our newly created nodes, so our if statement, and we're going to go down to the compile method and add in our if statement. So case node type dot if statement, and that's going to call a new function visit if statement. We do have a lot of new stuff to add into this compiler, so we'll go down to visit our if statement function. So we'll go to the bottom of all of our visit statements. underneath the sign. So def visit if statement self takes in a node of the type. We're going to grab all of our variables from our node. So our condition, consequence, and alternative. First thing we'll do is we're going to test our actual conditions. We'll name it test. And then this will be our type, but I'll just set it as an underscore because we don't need it. Self.resolve value. We'll pass in our condition. This will resolve whatever our condition equals out to. So if the alternative is none, that means we don't have an else statement. So we want to use something a little new. If you have used Python a lot, you've seen this. Same thing that we use for opening our file, but this with statement. So with self.builder.if then. So as you can see, there is a if then and an if else statement on the builder we're using. So after we pass in that test, we'll just call our self compile and we'll compile our consequence. So generate that IR code for that. So if there is an alternative, so we'll add an else statement here with self.builder.ifelse test, and we'll break these variables out from that function. First one will be true, and the next one will be otherwise. So I have a little bit of a comment I'm going to put in here just to help visualize what's going on. So this is just creating a condition branch. So if this condition is true, it's going to branch to whatever our consequence or if block code is in the actual execution of our code. And if that condition is false, it's just going to jump or branch straight to the else branch of this tree. So I'll keep this here just so you guys can see this. So with true, if this is true, so true is actually a value, we're going to compile our consequence function. So for our integer types, first, we'll go below this. I need to come back to this. I apologize. I forgot this was even a thing. So I'll come back to this POW symbol. But we're going to paste in these cases. So every single one of these comparison operations for integers in particular, make sure this is our integer if statement, it uses an ICMP signed. So you can create one of these, paste them all, and just change these symbols. And these will do our comparison operation and return back, and we'll move into our floats now. I'll paste these. You guys can pause and copy them as well. All of them use the FCMP, so float compare ordered. And you could just copy or make one of these, copy paste for all the other comparisons, and enter in the symbols on this function as well. So that's all we need for the infix expression function. We now need to scroll down a case statement into this. So below identifier, paste in Boolean literal. Right here again is just for IntelliSense. You don't need this at all. But this will return a constant with the type, and it's going to return 1 if the node.value is true. If not, it's going to set that constant's value to 0, and then it will return back that as well. All right, so that's pretty much implemented here. We do need to implement a couple more things for our actual Booleans, so actually registering the true and the false. So up here in our very top of our compiler in our type map, we're going to add the bool type. So ir.bool or int type 1, sorry. At the bottom of our init method, we're going to do a new function we're going to call is self underscore underscore initialize built-ins. We are going to declare that function right below the init. So initialize built-ins just takes in self and it won't return anything. This function is going to have a function within it just for fun. So init booleans. This will return a tuple of first value being a global variable, ir.global variable. The second value will be an ir.global variable as well. So this is where we're going to actually build our constants for true and false within the LLVM IR code. First thing is we're just going to extract this Boolean type. It's an IR type from our type map. First thing we're going to do is our true variable. So I'll paste these in for the sake of time. We're going to create a ir.global variable, passing in the module, and it will be our Boolean type. And the name of that global variable, or global constant pretty much, is true. We're going to make our initializer an IR constant. So it's going to be initialized to 1, which means true. And we're going to set that to be a global constant. Now you can copy paste the same thing and just change everything to false variable. So false here, and we're going to change this number to 0 because that represents a false Boolean type. And this is also a global constant. And from this inner function, we're going to return our true variable and our false variable. So we're going to return that tuple. Now lower down in the initialize built-ins function, we're going to grab out our true variable and our false variable from our init booleans function. And we are going to define these in our environment. So we can't name a variable true or a function true. This is going to be a reserved keyword. So the name is true. The value will be our true variable. And our type will be the true variable dot type. And you can copy paste this again for false. So just change this to false, false variable dot type. Now that this is set up, this function is gonna branch us into our built-in functions as well, and any other reserved keywords you want to add to your language. This is how you would initialize them here. So later down the line, when we get our printf function, this will be where we first set up that actual global pointer to that function. So we can go into our main.py file now, make sure our compiler is set to true, compiler debug is set to true, and we'll run that program again. We'll look at our IR code and we'll bring up our test.lime as well. So right off the bat, first two new things you'll see is true and false up at the very top. They're declared as a constant, so they can be used everywhere, and true and false cannot be changed. There'll be a compiler error and a bunch of other errors down the line. We define our main function, of course, in our entry block. We set our variable equal to 5. This is where we compare, so that we're going to load that A, and we're going to compare A, see if it's equal to 5. And this is where our branch is. So depending on what this comparison equals, if it's true, we're going to jump to the main entry if block. If not, if it's false, we're going to jump to the main entry else block. So in our main entry if, we're storing that 69 into A, and it's going to jump to the end if block. For the else, we're storing A equals 420, and then we're going to jump to end if as well. And this is where we load A and then return A back. So the IR code is looking pretty good, so I think we can go to our main.py. Let's bring that back. We can go to our main.py and set our run code flag to true as well. Run that. And as we can see, we do have an if statement. So A equals 5, so it reassigned the variable A to 69 and returned it back, and here we are. So I can set this to 1, so A equals 1, so it should set 420, and here we are. Perfect. So if A is not equal to 1, this should take us to 69.
3 hours later.
All right, technical difficulties. I completely forgot about the not equal statement in here. So if you caught that, good job. we're going to set not equal here. We're going to set not equal here. And we're going to test that. So, yep, that'll work. All right, so we will copy this down into our floats. And we'll use our FCMP ordered. That will be our integer type as well. Okay, so after that technical difficulty, you can now see that main.py is now a is not equal to 1, so it's going to return 69. So we not equal to 5, so a is 5, so we're going to get 420. So our if statements are conditional operators, and our booleans are now implemented, so feel free to play around with those. If you do notice any bugs, please hit me up on Discord, and I can make a patch video out. I think we're all good though now. If you have any questions, comments, concerns, please put it in the comment section or join our Discord. The link is in the description below this video. In our next episode, we're going to be going into function calling. So we're going to actually have external functions such as like an add function or a test function that returns something, and we'll return it back, and then we'll move on to episode 10, which is function parameters. So thanks guys for watching, and I will see you in episode 9.